The human sense of smell, also known as olfaction, is a complex and often underestimated sense. It plays a crucial role in our daily lives, influencing our emotions, memories, and even our safety. At the heart of this sensory experience lies the olfactory system, a sophisticated biological apparatus responsible for detecting and processing smells. This system, spanning from our nose to our brain, allows us to perceive and interpret the vast array of odors present in our environment. The journey of smell begins in the nasal cavity, where millions of olfactory receptor neurons reside. These specialized cells, located high up in the nose, are equipped with hair-like structures called cilia that extend into the mucus lining. When we inhale, airborne odor molecules dissolve in the mucus and bind to these cilia, triggering a neural response. This neural signal travels along the olfactory nerve, a bundle of nerve fibers extending from the olfactory bulb to the brain. The olfactory bulb, a small structure located at the base of the brain, acts as a relay station, processing the incoming signals and transmitting them to various regions of the brain for further interpretation. The olfactory system is intricately connected to the limbic system, a part of the brain responsible for emotions, memory, and motivation. This connection explains the powerful emotional and mnemonic associations we often have with certain smells. Smell is often perceived as a simple, primal sense, yet the reality is far more nuanced. Our olfactory system doesn't merely detect odors, it deciphers a complex symphony of volatile compounds, each contributing to the unique character of a scent. This intricate process goes beyond simply identifying an odor as pleasant or unpleasant. It allows us to perceive subtle variations and nuances within a vast olfactory landscape. The human nose can distinguish between thousands, even trillions of different odors. This remarkable ability stems from the diversity of olfactory receptors, each tuned to detect specific molecular features of odor molecules. When an odor molecule binds to a receptor, it triggers a cascade of events, ultimately leading to the generation of a unique neural code representing that particular smell. The perception of an odor is further shaped by the concentration of odor molecules in the air. Low concentrations might evoke faint or even imperceptible scents, while higher concentrations can lead to intense, even overwhelming olfactory experiences. This concentration-dependent perception adds another layer of complexity to our sense of smell, allowing us to detect subtle changes in our environment. Furthermore, our perception of smell is not static. It adapts and changes over time. Prolonged exposure to a particular odor can lead to olfactory adaptation, where our sensitivity to that smell decreases. This phenomenon, while sometimes annoying, prevents sensory overload and allows us to focus on new and potentially important smells in our surroundings. One of the most fascinating aspects of smell is its profound connection to memory. Have you ever noticed how a familiar scent can instantly transport you back in time, conjuring vivid memories of people, places, or events long past? This evocative power of smell stems from the unique neural wiring of the olfactory system. Unlike other senses, which are routed through the thalamus before reaching the cortex, olfactory information has a direct pathway to the amygdala and hippocampus. These brain regions are intimately involved in emotional processing and memory consolidation, respectively. The direct link between the olfactory system and these emotion and memory centers explains why smells possess such potent evocative abilities. A whiff of freshly baked bread might transport us back to childhood kitchens, while the scent of a particular perfume might evoke memories of a past love. These olfactory-triggered memories are often incredibly vivid and emotionally charged, imbued with a sense of immediacy that other sensory memories lack. This intimate connection between smell and memory has significant implications for our daily lives. It shapes our preferences, influences our moods, and can even trigger powerful emotional responses. For example, studies have shown that exposure to pleasant scents can improve mood and reduce stress, while exposure to unpleasant odors can have the opposite effect. This interplay between smell, memory, and emotion highlights the profound influence that our olfactory experiences have on our overall well-being. In the intricate tapestry of human senses, smell stands out as a critical player in our survival. While often overshadowed by sight and hearing, our sense of smell acts as a silent guardian, constantly scanning our environment for potential threats. This olfactory danger detection is deeply rooted in our evolutionary history, serving as an early warning system that alerts us to hazards before they can cause harm. From the earliest humans huddled around campfires to modern city dwellers navigating bustling streets, the ability to detect danger through smell has been essential for survival. The olfactory system's sensitivity to a wide range of airborne chemicals allows us to perceive threats that might be invisible to the naked eye. This includes everything from the obvious, like the smell of smoke indicating fire, to the more subtle, like the odor of spoiled food signaling the presence of harmful bacteria. This olfactory vigilance is not merely a passive process. It's an active and dynamic system that constantly assesses the environment for potential risks. Our brains are wired to rapidly learn and associate certain smells with danger, creating a powerful aversion that helps us avoid potentially harmful situations. For instance, the acrid smell of burning rubber might become indelibly linked to the experience of a car fire, triggering an immediate and instinctive avoidance response in the future. This innate ability to detect danger through smell is a testament to the power and importance of this often overlooked sense. It serves as a constant reminder that our olfactory system plays a vital role in keeping us safe and shaping our interactions with the world around us. Our olfactory system is exquisitely tuned to detect a vast array of volatile organic compounds, or VOCs, chemical messengers constantly released into the air from various sources. These VOCs, often invisible and odorless at low concentrations, carry a wealth of information about our surroundings, including potential dangers. Our noses act as sophisticated detectors, discerning subtle variations in these volatile whispers, alerting us to potential threats before they escalate into danger. One way our sense of smell alerts us to danger is through the detection of specific VOCs associated with harmful substances. For instance, smoke, a telltale sign of fire, releases a complex mixture of VOCs, including carbon monoxide, nitrogen oxides, and volatile organic compounds like benzene and formaldehyde. These chemicals, even at low concentrations, trigger a cascade of neural responses that activate our brain's danger detection circuitry, prompting us to seek safety. Beyond specific danger signals, our olfactory system also relies on pattern recognition to identify potential threats. Our brains are constantly learning and associating certain odor profiles with danger based on our past experiences. For example, the musty, earthy odor of mold might not be inherently dangerous, but our brains quickly learn to associate it with damp, potentially unhealthy environments, triggering an aversion that helps us avoid potential health risks. This ability to detect subtle variations in volatile compounds and recognize odor patterns associated with danger highlights the remarkable sensitivity and sophistication of our olfactory system. It's a testament to the power of smell as a sentinel, constantly guarding our well-being by decoding the chemical language of our environment.